Good morning, boys. I am your chemistry teacher, Shubroto. Welcome to my online chemistry class. Okay, today we talk about chapter 8. In this chapter, we discuss about chemistry and energy. We already know that chemistry is a vast knowledge and energy is very important to our daily life. All of us are performing to get the energy. We know when wood is burned, light is come from that burning, and all of we know that the fossil fuel like petrol, gasoline, methane, it is burned to get the energy. In this chapter, we discuss about the energy from chemical bonding. We already know that a battery can perform or give energy to get the to give some extra thing. We already know something about nuclear energy. In the nuclear energy, we know that in nuclear chemistry or nuclear energy is huge amount of energy is released from nuclear reaction. In this chapter, we discussed about energy which is evolved from our chemical bonding or chemical reaction. By the end of the chapter, we will able to know the reaction producing energy with chemical changes, releasing the importance of purity of fuel in energy production, limit of consumption this fuel for saving the environment, and show consciousness in selection of appropriate fuels. Then find out the chemical reaction related problems, prepare investigation plan, implementation and test its effectiveness, keeping the safety measure in mind. Take decision responsibly and spontaneously with confidence in performing chemical reaction and production of energy. Explain the idea of direct current using electronic connection. And so on. First topic is about source of chemical energy. We know that the matter has molecules and atoms. These molecules and atoms attach one another to form a bond. We know when a bond is formed, energy is released, and when we want to break down the bond, we have to apply energy to break that bond. So the bond energy is the energy by which an atom remains joined with one another atom is called bond energy. In sodium chloride, there is ionic bond between sodium ion and chloride ion. Then we go to the intermolecular energy. In intermolecular energy, when a covalent compound, the energy is that keeps the molecules combined with each other is called the intermolecular energy. For example, we can say about water. In water, two atom of hydrogen combine with one atom of oxygen, and it will produce one molecule of water. And the energy which needed to attach with a ionic bond is called ionic compound, and that energy is more than the covalent compound. That's why the melting and boiling point of ionic bond is higher than the covalent compound. Like sodium chloride, the melting point is 801 degrees Celsius, and uh, boiling point is 1465 degrees Celsius. On the other hand, the melting point of water is 0 degree and the boiling point is 100 degrees Celsius. Here we uh, highlight the important line of that chapter, that page. In the next topic, we discuss about transforming of energy in chemical reaction. We know that when a chemical reaction is occurred, uh, a molecule is transformed into another compound. That means a bond is reformed and produce a new bond. This bond, when reformed, some energy is taken from the environment and some energy is released to the environment. So in that transforming, new bond is formed. Here, each substance contains some energy. Usually in chemical reaction, the energy of the reaction is necessary to make the reaction happens, or some chemical reaction result in generation energy. Energy required making a reaction happen or resulting energy from reaction may different from like heat energy, light energy, electricity, sound, etc. Unit measurement of energy. We already know that the unit of energy is joule uh, and kilojoule, and the other unit is calorie. The definition of calorie is the heat applied to raise the temperature of 1 gram water (1 degree Celsius) is called a calorie. Kilocalorie means 1000 calorie. Classification of chemical reaction according to the change of heat. It is symbolized as delta H. We already know that reaction are two types, exothermic and endothermic. In exothermic reaction, energy is evolved, and in endothermic reaction, energy is needed to continue the reaction. When an exothermic process, delta H, the change of enthalpy is negative, and in endothermic reaction, the delta H is positive. The formula to calculate the energy which is evolved or energy is needed for the reaction are given in that formula. Delta H equal to internal energy of the product minus total internal energy of the reactant. If we want to calculate the energy released, we have to know this formula. In exothermic reaction, the internal energy of reactant E1 and internal energy of product is E2. Therefore, the value of delta A is equal to E2 minus E1 becomes negative. Example of some exothermic reaction are given. When calcium oxide react with water, it will produce calcium hydroxide and 63.795 kilojoule per mole heat in that reaction. In endothermic reaction, the delta H is always positive. Example of endothermic reaction is preparation of lime from oyster. Calculation of heat change in chemical reaction using bond energy. We have to know some energy which is needed to break the bond, or the energy which is evolved when a bond is formed. That energy is called the bond energy. So if we want to know the reaction, the energy which is evolved from the reaction, we have to know the bond energy of that molecule which is needed to form that bond. Here we discuss important line of that topic. Here we discuss the formula of that energy which is needed for breaking a bond or releasing energy from that bond. The delta H is equal to total bond energy of that reactant minus total bond energy of the product. If the delta H is negative, then it will be exothermic, and delta H is positive, then it will be the endothermic. So we have to know the bond energy of that molecule. In this slide, we discuss the bond energy of some bond. Here, carbon hydrogen, the bond energy is 414, carbon 344, nitrogen 996, and so on. We don't need to memorize this bond energy in any math. We have this value is given in the question for solving math. Here we discuss a math determining the heat change in the reaction methane plus chlorine, the production of methyl chloride plus hydrogen chloride. Given that the bond energy of hydrogen and carbon is 414 kilojoule per mole, carbon chloride for 244 kilojoule per mole, and hydrogen chloride is 431 kilojoule per mole. We discuss this math in practicals and go to the next slide. Here the math is written in my khata. Methane plus chlorine react to form methyl chloride plus HCl. In my structural formula, here 4 bond of carbon hydrogen and 1 bond of chlorine, and in the product 3 bond of carbon hydrogen and 1 bond of carbon chlorine and 1 bond of hydrogen and chloride. Here, given that the bond energy of carbon and hydrogen is equal to 414 and carbon and chlorine is 244 and hydrogen and chlorine is 431 kilojoule per mole, we have to know that here only 1 bond of carbon hydrogen is break and 1 bond of carbon chlorine is formed. and one bond of chlorine is broken and one bond of hydrogen chloride is formed. That means if we want to know the bond energy, we have to calculate or summation of the bond energy of carbon hydrogen and chlorine, and we have to know the carbon chloride and hydrogen chloride. Here one bond is not given, which is chlorine and chlorine bond is 244 and carbon chlorine bond energy is 326. Then the bond, the energy is needed to broken the reactant is U1 equal to bond energy of carbon hydrogen plus bond energy of chloride is equal to 414 plus 244. Then the energy is evolved by the new bond is E2 equal to bond energy of carbon chlorine plus hydrogen and chlorine. That means 326 plus 431 equal to 5757. So the bond energy equal to E1 minus E2, 658 minus 757 minus 99 kilojoule. So delta H equal to minus 99 kilojoule. So it's negative and this reaction is exothermic. Okay, it is the mathematical problem for this reaction. Today's class is end by this solving this math, preparing some maths from your test paper. Stay safe and stay at home. Thank you. Be safe.